KIABEX is open, interoperable and modular, allowing it to integrate seamlessly with existing infrastructure and eliminating the risk of lock-in that often occurs in traditional software products. By using open data formats and open languages, KIABEX ensures availability across the widest possible spectrum. All code is version controlled in a secure Git repository and is available for external consumption and reuse. Our KIABEX platform can be used as a SaaS offering on the infrastructure of most cloud providers, such as Amazon Web Services, AWS, Google Cloud, GCP, or Microsoft Azure. With any of these data systems, KIABEX leverages cloud-first technologies such as modular microservices architecture and distributed computing. KIABEX also has well-documented REST APIs for interacting with the compiler system, managing data state, and exploring metadata and other information in the KIABEX ecosystem from third-party applications. KIABEX enables telcos to deploy expert quality applications to address their problems, from intelligent fault prediction. KIABEX offers advanced proprietary technology and a portfolio of out-of-the-box applications specifically designed to optimize telco operations, enabling customers to customize and deploy solutions for users in days, not months. KIABEX's range of privacy and security capabilities enables telcos to keep up with changing regulatory requirements, such as those mandated by GDPR and CCPA, and even go beyond what is required to protect the privacy and identity of individual customers. Beyond standard access controls, KIABEX also enables users to apply dynamic data minimization procedures, such as sodomization and encryption with purpose-based disclosure, to meet the complex requirements of relevant data protection regulations. Designed for a low floor and high ceiling in terms of user workflow complexity, our frameworks support developers of a wide range of use cases, from Spartan applications for a small group to mission-critical applications at the heart of operation centers. Customer-centric network management integrate telemetry data from your core network with data from the enterprise support system, OSS/BSS, to obtain information that can be used to perform preventive network maintenance, inform engineering, and support functions to deliver new services and improve the customer experience, such as proximity check, 360 degrees technical client, network upgrades, 5G CapEx deployment, non-conforming order alerts, cable degradation alerts, outage management, decommissioning management, customer service with a single shared view of your customer's data and usage history. You can leverage timely information to deliver exceptional customer service to all customers, consumers, B2B and other third parties. Such as predictive ticket routing, product and service analytics, network upgrade monitoring, service level agreement compliance, third-party call center, callback enhancement, field engineering support, and streamline your entire crew engineering process, from allocating the right resources to respond to problems, to planning and executing network upgrades and expansions, equipment alarms, incident management, fleet maintenance, technical performance monitoring, cable location, intelligent surveying, supply chain. Create AI-driven supply chain operational network models so you can leverage data-driven insights to reduce costs, optimize capital expenditure and minimize operational expenditure. Equipment management, order fulfillment, quality of experience through transparent sourcing, equipment price negotiations, cash flow reduction, sales and marketing. Optimize marketing, pricing and services across the entire customer lifecycle. Gather data on usage patterns, service quality, and customer experience into a single source of truth and use it to drive your marketing and sales decisions. Customer 360. Home view. Cross-selling. Selling. Next best offer. Portfolio optimization. Our winning cases. Case 1. The complexities of a fiber network coverage and unexpected outages limited our clients' ability to determine root causes and the optimal actions to be taken globally. The result was a degradation of service quality and an increase in customer support costs. Case 2. In telecommunications. Complete visibility of network assets, the customers they serve, and the technical problems that arise pose a complex challenge of determining root causes and the optimal actions to be taken at the global level. Today, previously siloed teams can work in a unified ontology, driving mission-critical use cases across the enterprise, and helping to reduce costs and ultimately increase customer satisfaction. The sales force focused their blind commercial efforts, looking for customers where they were not, or in some cases the competition already had the coverage. Therefore, an AI was implemented to deliver information in real time through the cell phone, indicating where the customers are according to the required characterization. The most advanced technology was created, processing millions of data in big data to deliver commercial indicators KPI via web, mobile that meet the commercial objectives, according to sales profiles. Sales increases of over 40% per region, optimization of commercial staff time by 90%, improvement of customer service by 65%. There was no real-time system to monitor the installations and status of work orders, change or renewal of technology versus actual status. Control robots were supplied for real-time inventory consumption, tools, events, notifications, corresponding traceability and workflow of the installation process. Our intelligence allows us to make decisions on all events captured in the field, samples captured, data analysis, anomalies by points, problems detected. Through an interconnected interface, they delivered preventive information to failures. Neural networks prevented failures of services to customers, attaching predictive evidence along with KPI performance indicators, obtaining its results. Increased number of installations. Technological renewals and the NPS indicator increased by 35%.